What's up? I'm Vin, and today I want to show how to use the unit circle to evaluate trig functions. So we have these notes here, and we want to go through a few questions. And the way this formula works, that any point xy corresponds to cosine theta sine theta, where theta is the central angle formed from standard position. I just want to go through a quick derivation of where that comes from. So if I look at a rough sketch of the unit circle, so here's the unit circle here, and I just focus on any point, let's say this point over here, xy, and let's just write that in neater so we have xy, then the distance from the origin to this point is going to be equal to 1 because the unit circle has radius 1 and it's centered at the origin. And to get to that point, I'm going to go to the right x and I'm going to go up y units like this. So I'm going over x, up y, and it makes a right triangle. And then this angle in here is going to be theta. So when we talk about theta, it's referring to the angle from standard position. And this is what we mean by any point xy on the unit circle. So if you think about it, if I use basic trigonometry here and say, well, what is cosine of theta? Well, notice adjacent to angle theta is over here. That's the side that's x units long. Over the hypotenuse across from the right angle is 1 unit long. So that tells you cosine theta is equal to x. So that's where the correspondence between x and cosine theta comes from. And if I want to look at sine theta, I just look opposite of theta is y, and I'm dividing by the hypotenuse of 1. So that tells me why sine theta is equal to y. So that's just explaining kind of like where this formula comes from. But now if I want to use the unit circle just to evaluate trig expressions, I could just trust that this formula works after we go through a proof. But I just want to think about these 4 points on the unit circle. Because remember, centered at the origin, if I go to the right 1 unit, I'm here. If I go north 1 unit, I'm at 0, 1, and so on for the other points. That for me to get to, let's say, the point 1, 0, I have to spin 0 degrees from standard position. Because remember, standard position starts on the positive side of the x-axis. If I want to get to the point 0, 1, I have to spin 90 degrees from standard position to get here. If I want to get to the point negative 1, 0, I have to spin 180 degrees. To get to 0, negative 1, I have to spin 270 degrees. And then to get back to 1, 0, I could also spin 360 degrees. Just know I could also go in the negative direction here. 270 degrees, I could also get there by spinning negative 90 degrees. But I just want to focus on the positive angles to start. So now the way these questions work is that anytime I want to find something, let's say like sine of 90, this tells you where to spin. And this tells you which coordinate to look at. So the first thing I'm doing is I'm spinning 90 degrees. So if I want to find sine of 90, I'm spinning 90 degrees, but the fact that I'm looking for sine of 90, remember, sine refers to the y coordinate. So really what this question is asking is what is the y coordinate? So what is the y coordinate when we spin 90 degrees? Okay, so it really helps to just be able to rephrase these questions in your head. So then when I want to answer, well, what is sine of 90 degrees? Well, we spin 90 degrees and we are at the point 0, 1. But remember, cosine is the x, sine is the y, and the y value there is equal to 1. Okay, so just say this a few times. The way you could remember this, you could also use the fact that x comes before y in the alphabet. So if I look at cosine theta and sine theta, c comes before s in the alphabet. So that's one way of remembering. But just know the x corresponds to cosine and y corresponds to sine. So it takes a few tries to get good at these. But now sine of 180, first thing I do is I'm going to spin 180 degrees from standard position. So I'm going to spin to the point negative 1, 0. And now the fact that I'm looking for sine of 180 tells me to look for the y value. What is the y value when we spin 180 degrees on the unit circle? The y value is 0. So question 2, the solution is going to be 0. And now if we move down the list here, cosine of 180 is similar to question 2, but I'm spinning 180 to the point negative 1, 0. But now if I'm looking for cosine of 180, I'm trying to look for what is the x value at this location. And the x value when I spin 180 degrees is negative 1. So that's going to be our answer to 3. And now these questions can get a little bit trickier, but let's say I want to go sine negative 90. Remember, if I go positive 90, I'm spinning counterclockwise. I'm going this way. So if I'm going negative 90, that's the same thing as going 270 degrees. So this once again tells you where to spin. I'm spinning to the point 0, -1, and the fact that I want sine of -90 is really asking what is the y value at this location, and the y value is -1. So that's our answer to 4. If I want cosine of 270, notice 270 degrees, if we're spinning 270 from standard position, that brings us to 0, -1, and cosine is referring to the x value. So I'm really asking the question, what is the x value on the unit circle when I spin 270 degrees, and the x value here is 0. And now for the last one here, what is cosine of 0, is asking what is the x coordinate on the unit circle when I spin 0 degrees from standard position, and the x coordinate is equal to 1. Now the only way these questions can change slightly is sometimes they give you an equation and they want you to solve for the angle itself. So really what we're solving for now is the spin. So what I'm looking for, if I say sine of theta is equal to 1, I'm looking for where is the y coordinate equal to 1. So this is what I'm thinking of in my head. So where is the y coordinate equal to 1 is the question. So if I look at all these y coordinates, the y coordinate is equal to 1 at this location here. So how many degrees do I have to spin to get to this location? I have to spin 90 degrees. So this tells me that theta is equal to 90 degrees. And notice this is the only solution between 0 and 360 because our y values are only equal to 1 at this location up top. At no other point am I going to reach a y value of 1 except at this point on the unit circle. Notice that the interval is restricted to between 0 and 360 because if I'm allowed to spin more than once, then I have infinite answers, but restricting the domain leaves us with just one solution. So now question 8, what we're trying to look for here is we're trying to look for when is sine of theta equal to -1, but once again, remember the idea that for any point xy is equal to cosine theta sine theta. So what we're really looking for is if we're trying to find out when sine theta is equal to -1, we're looking for when is the y coordinate equal to -1. And the y coordinate is equal to -1 only at this location down here. So only at this spot when we spin 270 degrees. So I would say here that theta is equal to 270 degrees. I could also say -90 degrees. However, -90 is not between 0 and 360 degrees. So remember, our answers have to be strictly between 0 and 360. So we have one answer for question 8. Now for question 9, this is a question that could get you into trouble if you're not careful. Cosine theta is equal to 0 is asking you, remember cosine is the x coordinate. So we're looking for where is the x coordinate equal to 0. And we have an x coordinate equal to 0 at this location here up top. See, when we have the point 0, 1. And we also have an x coordinate of 0 down here at the point 0, -1. So in this case, we actually have two solutions between 0 and 360. We have an angle of 90 degrees, and we have an angle of 270 degrees. So these are the only two locations when we're spinning between 0 and 360 where x is going to equal 0. And now for the last one here, we want to know cosine theta equals -1. What is theta? Well, now we're looking for where is, remember cosine is the x coordinate, where is the x coordinate equal to -1. So x equals -1 is to the left one over here. And this is the only location on the unit circle where the x coordinate is equal to -1 at the point -1, 0. And to get there, we have to spin 180 degrees. So we would have theta is equal to 180 degrees. Technically, I could spin -180, but remember, our answers have to fall between 0 and 360. So this is going to be our solution to the last question. Okay, well, this is going to conclude this video on using the unit circle to evaluate trig functions. If this video was helpful, please like and subscribe. It really helps me grow the channel. And if you got any requests, just leave a topic or topics you want me to cover in the comments section below. And thanks for watching.